everyone! How is it going? Today, we're gonna be learning... the New Testament of Rosemi. We're gonna be having a reading together. We're gonna be learning about it. We're gonna be going a bit in depth about it. I hope you brought your books today. I hope you brought your books. We're gonna be starting with the Book of Rosemi. Verse 2. Book of Rosemi. Verse 2. Alright, please open it up. Wait. Oh crap! I'm sorry, wrong stream, wrong stream. This is meant for another time. This is not meant for today. Okay, this is... No, this is not meant to... Oh, sorry. Okay. Oh, God. Okay. There you go. Wrong stream, that's for another time. That was not for today. This is not the scheduled stream. There you go. Timothy Chalamet, thank you so much for joining. Wow. What the hell? I don't know why there's so many Timothy Chalamets in my chat. I don't know. Are they like... You guys like... Is it just like one guy with 1 billion Timothy Sock accounts? I don't even think so. I think they're becoming sentient. I think they're all... their own Timothy Chalamets. Okay. Whew. Okay, today we are gonna be learning. It is our third astronomy stream. Sorry guys, I got it wrong in the beginning. The New Testament of Rosemi stream will be at another time. Sorry to disappoint you guys. Oh! Timothy Chalamet, thank you so much for the gifted. Wow, I hope Timothy Chalamet gets it. I don't even know who is who! You will have varying zoom-ins of the same some reason, some of them have accents on his name and some don't, and some are like typed differently. I don't know what the hell's happening. Anyways, we're gonna be doing our third astronomy stream, space stream today. We did two once in the past, but it's been like what you see, girl. No, I don't, Timothy Chalamet. What's it? All these fake accounts? I'll report this to YouTube. Don't worry, Rosemi. In parentheses, real. We are Legion. I can see. I can see. But yeah, we've done 2 streams in the past of astronomy, and if you're interested, please definitely go check them out. My plan originally was to kind of like get a bit more in depth every single time. Maybe not. I don't know. Like I didn't want to say like harder because I don't think it's like harder per se. Although I think after this, if I ever do a 4th one, I will start like going into like maybe a bit more like equations and stuff. I don't know. Maybe we'll see. I don't know. That's a bit too much though. But the plan was to go a bit more in depth. So I don't know just how much more in depth it's gonna be because it is hard. Like obviously, you know, there's a limited amount of like knowledge about this type of stuff. But yeah, we're gonna be checking a bit more stuff. These are particularly some stuff that I think are like really interesting, so I hope that you can also appreciate it, what we're going through today. And we have some images and stuff to go along, and as usual, you know, I tried to make it as easy to understand and condense some stuff a little bit. So yeah, I have some notes here, and I wrote so many notes. I have literal pages and pages and pages of notes, so... Yeah, we're gonna be going over Arrakis. I love your astronomy streams. I rewatch the first 2 VODs every couple... What? That often? Jedi, thank you. Rosemi, you gotta help me. The Timothys are trying to assimilate me. You gotta stop them before it's too late. Oh god. I think it was too late. Syntax, thank you. Or should I say Timothy? Okay, you ready? Okay. Let me get rid of this choir music, which is not for today, by the way. The New Testament of Rosemi stream is another day. I repeat. Okay, so let me get my I made a folder, but I called it Astronomy. Who are these Timothys? I don't know. They're scary. There's too many of them. You wanted to get a telescope? You should. I don't have one particularly. I want to get one too. But I'd like to get a nice one if I ever did. Okay, Yosh! Yosh. Here, let me... One second. Let me put the blackboard over my wings, because I feel like my wings are kind of... Oh. Okay, never mind. I can't find it anymore in my OBS. I am the real Timothy Chalamet. Don't listen to the other Chalamets. Or Timothy... Huh? Thank you, Timothy Chalamet. Wow. Okay, so the first thing we're gonna be going over in our things that we will be reviewing today is... Should I... Here, I'm gonna like write a little like... subject. Okay. Let me make this a bit more legible. Oh, maybe like a blue. I spotted the first point of Aries in your telescope. Really? That's Timothy Chalamet! You're into astronomy? You didn't tell me. Wow. Or is every Timothy Chalamet different, you know? How does it... Oh, cool. Cool. Okay, so the first thing we're gonna be I know I never changed the fonts. I'm like, whoa, it's fancy. That is true. I guess for a telescope, it really depends where you live, also, and stuff like that, right? Oh, is the BGM loud? Is it fine? Let me know. Let me know. If it's okay, then we shall begin. We shall begin. It's alright. Okay! These pictures are free to use. Thank you. Arigato. For educational purposes. Here we go! Okay, so the first thing we're gonna be going over are stars, and we went over stars a little bit before in some of the previous streams. So let's see what more we can talk a bit more about them this time. So, if you guys didn't know, there is an estimate, and obviously this is just an estimate. Obviously, you know, we'll never really know. Maybe one day in like a billion years where our technology gets really, really good. Or our understanding of space gets really good. But there is about a septillion stars in the known in the universe that we are estimating there to be. Which is 24 zeros. 24 zeros. I've literally never heard the word septillion, and now I have. So, yeah. There is 24 zeros in that. So now it's 20 times 20 with 24 zeros at the end. Your eyes are like stars. Thanks. That's why I made them like this. That is a lot. So I keep looking at your icons, and then I see this one Timothy Chalamet with a really zoom in on his face, and I don't know why that pisses me off for some reason. Okay, so yeah, and in our Milky Way, there is about 100 billion stars. So then that we know of, there's an estimate of 1 septillion, but in our Milky Way itself, so you know, a bit closer to home, there's about 100 billion stars out there, which is crazy to think about, you know. Just almost as there's almost as many Timothy Chalamets in this world as there are of stars in the Milky Way, if you want to think about it that way. Now, if you think about like how infinite and like large the universe is and the space between them, that's crazy to think about, you know. I don't know, it just like boggles my brain a little bit. These stars have an approximate, I think I've talked about this a little bit vaguely in the past streams, but these stars have an approximate lifespan of a few million to trillions of years. And you know, it's all depending on, you know, their like mass and their size and stuff like that. Yeah, each Timothy Chalamet is a star themselves. And yeah, so stars are, you know, mostly comprised of hydrogen and helium, and then you have a small amount of other stuff. And I'll be mentioning hydrogen and helium a lot today, so you know, just if you want to keep your ears on, you know, pointed for that. Yeah, we're gonna be mentioning those two elements a lot. So we're just a grain of Timothy Chalamet, da 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 na 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 na, expanding through the sky. Hi Rosemi, you're my favorite twink streamer. Thanks! I'm not a twink currently, but I sometimes am. I sometimes am a twink, but not right now. Rusty, thank you. Thank you. Yeah, the hydrogen watch. Okay, so now here is the way that stars are born. So I'm like the Hulk, but with twink, exactly. So stars are born in clouds of gas and dust. I wrote gust. I think I've been thinking about Gustavo Fring too much because I wrote gust. So clouds are born in clouds. The stars are born in clouds of gas and dust, which are like a kind of like molecular clouds, and these clouds can be basically like 1,000 to 10 million times the mass of our sun. And these clouds of dust can span like hundreds of light years. Gustavo Fring. Gustavo Fring. Which is crazy. That's like hundreds of light years. Or like just like a mass of like gas and like dust can span such a big distance, which is like really, really crazy. The gust must flow. Shut up! Shut up, Twinkathy Chalamet. And yeah, these clouds, basically, they're... I'll be talking about these a little bit later also in another, you know, subcategory of topic. But these clouds are cold. So they're like really, really cold. And basically what they do is like they make like a hot, like this like super high density like pocket where they like keep colliding and collecting over time. And then like the gravity makes like to some point they like end up having so much gravity that they collapse, and then that the friction that it makes will make like a little baby star. So that's how the stars are born, aka Timothy Chalamet. Rosemi-sama, may I get a special Twinkie Nerd's birthday greeting for your Oshi? Okay. Twinkathy, Twink Rosemi. Okay. Let me see if I can find her. Him. Man, my like files are so disorganized right now. Where is he? Where's the Twink? Where's the Twink? Is the Rosemi star born this way too? Yeah, I'm like a mass of gravity. Unfortunate day for a birthday. At least I don't know. I feel like it's kind of cool. I'm not gonna use you as an image. Shut up. I'm trying so hard to focus right now. And there's so many Timothys. Okay, 1 second. I'm trying to get my icon. You know. My little twink icon. Here we go. Well, happy birthday, I guess, Michael. Okay. So my brain right now is so distracted by so many things. Let's keep going. Let's keep going. Twinksumi is a Tsun too. No. I picked the best day for doing a serious stream. I know, this wasn't planned. Like, I already planned out to do it on this day of the week. And then I found out, and then I remembered it was April's Fool's. And then it really pissed me off because I'm like, everyone's gonna think the stream is a joke, but it's not. Okay, let's continue. So that's how little baby stars are born. Dofio, thank you for the raid. I don't know. I saw you were doing some eel thing. I don't know. Did your eeling go well? Welcome. We are learning about space, everything about space and the universe and star. Well, currently we're talking about stars. So, yeah, drop sides if you'd like to stick around. Feel free to, and then maybe you can learn a thing or two. Oh yeah, and ignore all the like 50 billion Timothy Chalamets in chat. I don't know why that's a thing. He showed us his feet. Okay. Wow. Well, who am I to judge? Yeah, okay. And so there can be like clusters of these stars that are made from these clouds. So basically there can be like a lot of these little like stars or these like little baby stars made kind of like that would make a cluster. A stellar cluster, if you will. Rosemi, I'm traumatized. Don't worry, you are in a safe space right now. You're in a very safe, timeless space currently. We were eeling it? You were eeling it? Is that what you did, Topio? Damn. Okay. Okay, so continuing on. So basically, the heat from the initial like energy that collapses to make a star, basically it's like million and million of years of like pressure that make like the core kind of like squeeze. So basically like the hydrogen atoms kind of make like helium, which is a process called nuclear fusion, which I'm sure you've heard of before. And basically this makes energy to make heat, which prevents the star from collapsing under the force of gravity. We were really eeling it? Wow. And so stars that are in this process are called main sequence stars. Like when you do a lot of crunches. Exactly. Can you put in terms of eel? Okay. Basically, you have like let's say like there's like a hot part in the ocean. No, let's say there's a cold part of the ocean that attracts a bunch of like eel eggs, right? So it attracts a bunch of eel eggs. And then at some point, I guess there's like so many eel eggs in one area that like the eel eggs kind of collapse on themselves, and then they make one baby eel. And then the baby eel has so much like pressure and stuff that the hydrogens in the baby eel become helium, which makes heat, which stops the baby eel from becoming eel eggs. Does that help? Does that help? Yeah, hot eels in your area, exactly. That's how it works. Yeah. Okay. Forget eels. Forget eels. That did not help. Okay, I don't know. He's the one who wanted to know in terms of eels. So, continuing on, the stars that are in the process of nuclear fusion are called main sequence stars, and this is the longest like span of a star's life. So there's multiple there's multiple steps in a star's life, kind of like, you know, how we can be a baby and then we can be an adult and then we can be like a old person. You know? So the stars kind of have that too, and the longest part of their life is called main sequence. It's basically during this process of when a star is doing nuclear fusion for a very, 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 very long time. That was very helpful to understand. You're welcome. Over this phase in its life, the star kind of has its like appearance, and the temperature kind of changes a little bit. But yeah, basically, as I said before, the lifespan of the star will be determined by its mass. So the lower the mass, the longer it will live, and then the higher the mass, the less longer it will live. I just explained the meaning of life. Yeah, this is just like Mario Galaxy. Exactly. You get it now. Okay. So if everyone is good up till this point, let's keep going. What is the twinkest part of a star's life? Oh. I guess that would have to be it, right? Because you can't be... like, you cannot be a baby twink. I mean, I guess you could be a baby twink, but... Okay, so the end of a star's lifespan, like, you know, when it's like when it starts to become an elderly person, is when basically the hydrogen starts to run out, and then when there's no more hydrogen, it cannot make any more helium, and then things start to get bad. Oh, I just realized I had this little hand, but I don't need it yet. In fact, I don't even know if I'll need it at all. But you know what? I like to like wave it around a little bit. It makes me feel a bit smart. Cute, thanks. So when it starts running out of hydrogen to make helium, then we're like, uh-oh. The star's like, uh-oh. And then at this point where it cannot make any more helium with the nuclear fusion, the core will kind of begin to collapse on itself. So remember I said that before, the reason this collapse did not happen was because it had energy to make heat, which was preventing the collapse. But now, you know, there's that energy is no longer there. So basically, it'll keep like kind of like the temperature and the pressure. The pressure will go up. The pressure will go up, which will make like the star kind of like swell up a bit. But then each star has like its I mean, you know, depending on its mass and like characteristics, they'll each have their own like type of death, you know, like everyone dies differently. It's a bit ominous to say, but it's the same thing for stars. But yeah, basically lower mass stars usually will keep expanding until it becomes a giant. Where the helium becomes carbon in the core. So the remaining helium will become carbon. And basically this is the process that will happen to our star at some point in the future. The helium will start becoming carbon, and then, yeah. then yeah. Some giant stars will become a bit like unstable. And then basically like the outer layers will kind of like blow out a cloud of dust and gas, kind of like what it was born in. So basically this is what we see here. This kind of cloud of dust and gas that it will eject will make a nebula. It'll make a nebula, which is basically this image right here. Yippee! If we get outer wilds, I'd spend my last moments with you. Oh, thanks, Timothy Chalamet. It looks just like Spice. It does. I hate that. I hate that. Yeah, that's when it becomes Spice. Yeah, this is a really pretty image. Here, let me make it a bit bigger for you guys. Isn't it pretty? This is so pretty. Look at it. It does look. It's pretty Spice. Okay, so yeah, that makes a nebula. And then the last remaining part of our star is the core, which is a white dwarf, which will become a white dwarf. And the white dwarf can kind of basically be like the size of our planet. So it can be kind of the size of Earth, and it'll cool down over billions and billions of years. The nebula looks yummy. Here, what image do I have? I have our sun. Here's our sun. This is our sun. Our sun is beautiful. Shut up, Timothy. Hi, son. I'm dad. You sure? That's her bad side. Hey, what do you mean? That's so pretty. So yeah, where were we? Oh yeah, white dwarfs, and then yeah, basically yeah. White dwarfs can basically be the size of our Earth, and yeah, it'll cool down over billions and billions of years. However, so that was for stars with lower mass, but which tend to live longer, as I mentioned. Now, stars with a higher mass, basically will. It's a bit more of a. I don't know. Is it more? It's more of a funnier process. I don't know about saying it's more complicated, but it's kind of funnier. So, stars with a higher mass will basically convert, the helium, the hydrogen that becomes helium, and then after that, it'll have carbon, and then the carbon will become like oxygen and magnesium and a bunch of other stuff. And so, the fact that it'll convert it into more stuff will make even more fuel for the core. So then it's like, hell yeah, let's go. I got a little bit left in me. And then basically, now here's where it gets funny. So basically, the silicon, it'll be oxygen and magnesium and then silicon, and the silicon will become iron. And then basically, the core will basically give itself new fuel, but it'll last less and less every time. Every time it'll become something else. For example, like the iron will like not last at all, So when it goes after a few million of years, which is in the overall terms of like a star, not very long, right? When it'll have silicon, and the silicon will become iron, it'll only have a little few days left of fuel left. It'll be like, no, why? So basically, it'll eat at itself, and it'll only have a little bit left. And then it'll keep trying, but then it won't have enough energy to fuse this iron into something else, because it won't have any energy left. So, yeah, it's really sad, but it's kind of funny at the same time. Yeah, like StarCraft, I guess. And so then, yeah, it gets hungry, but then at this point it gets so hungry that it'll collapse, creating a big shockwave, which will make a supernova, which is the name of one of my wives. And they'll make a supernova, and basically the core of the star will survive as either a neutron star or a black hole. So this is, yeah, the Vespine gas, exactly. Yeah, and then the matter that kind of comes out of this big shockwave also gets used to make, you know, new baby stars. It will go and it will make more of these like clouds of dust and gas, and will make lots of new baby stars. So yeah, it's kind of like the cycle of life, you know. That'll happen in 7 billion years. As I mentioned before, our sun is not like one of the higher mass ones. It's one of the lower ones, so it'll become a white dwarf. So yeah, that was. Oh, whoops. So that was stars. Let me see what other images I have that could. Whoops. So this is our sun. And here we have another nebula with a bunch of planets next to it. Our sun is twink size. Yeah, our sun is twink sized. So this is another nebula with a bunch of I know. Yeah, it looks like an eye. It's kind of scary, isn't it? Kind of scary, isn't it? It's really pretty to look at it this way. And then here we have the remnants of a supernova. This one looks a bit disturbing to look at. I don't like looking at this one. I don't know, there's something about it that unnerves me a little bit, you know? Is the moon made out of trees? Yes. And there is a bunny making mochi on the moon. Okay, next up we will be talking about. Let's talk about galaxies, but let's talk about like different types of galaxies and stuff like that. So, here's our first image. Oh, this is the Milky Way. Did you recognize it? It should be familiar to you. This is us. Yeah, you should recognize it. It should be like your neighborhood. Tag yourself? Yeah, where are you? Okay, so yeah, next up we will be talking about... I think I'll get to see Betelgeuse explode. Oh my god. Every time I see that name... I think about that creepy character from ReZero, or I think about the Monhan dude, and I'm like, stop. Oh, thank you. New GeoGuessr update, yeah. Find out what part of the Milky Way this is. Okay, so let's talk about some galaxies and stuff. So, galaxies basically are kind of like categorized by their, you know, their like physical aspects. You know, like twinks. But, you know, some of them can be categorized, for example, by having like a black hole in the center and stuff like that. So, where does space end? Where the love for Rosemi ends. So this is, as I mentioned, this is our Milky Way, and our Milky Way is part of a type of galaxy which is called spiral galaxies. As you know, as you can kind of see, very fitting for the name. So it will never end. Exactly. So, So this is a spiral galaxy, and it has kind of like arms. So most spiral galaxies will kind of have like you see like the little like ends of it and stuff like that, kind of like the little arms that they have. And yeah, there's usually like a concentration of stars in the middle, the most middle part here, as that you can see. And Is there a square galaxy like Minecraft? There could be. I mean, technically there could be. There could be. Spiral galaxies, as I mentioned, tend to have, you know, like a cluster of stars, especially in the middle. But, yeah. And it can have, I think spiral galaxies tend to have a lot more of like older stars. So there's like a lot of like more older stars in this type of galaxy type. And basically how it works is younger stars will kind of form in like the arms, like the outer parts, which are kind of richer in like a bit more gas. So there's a bit more gas here that is good for like the formation of like stars. So there'll be a lot of newer little babies in this part, but then the older ones, like the elders, the elderly stars will be in the middle. Which is called the disk. This is called the disk. Obasan, yeah, the Obasan stars will be right here. And yeah, there's as I mentioned, you know, there's like a lot of different subtypes of, you know, there's like different categories, but there's also subtypes of these galaxies. So you can have like barred spirals, which is basically what the Milky Way is. So this is like a barred spiral, and also our neighboring Andromeda is also like that. And yeah, these type of barred spiral galaxies tend to have like dust and stars that kind of cut across the center. So like what you see right here, it'll be like pew. There'll be a lot of dust and stars here in the middle. What scientists think is that they think that means like the galaxies have matured if they have this little like cut across with a bunch of dust and stars in the middle. But we'll go over a lot of different types of galaxies, and you'll see that like basically based on their physical aspect, there'll be like theories of them being like a certain type of stuff. So let me pull up oh no. Let me pull up my images. So next up, let's talk about... Where's the image? Here you go. Elliptical. So this is an elliptical galaxy. As you can see, it kind of has this like elliptical shape going on. It kind of has this elliptical shape going on, which is honestly, it's a bit less common. You know, it has like this like round or like oval type shape. It's actually elliptical types of galaxies are less common, and they usually have a smaller amount of gas or dust. So as you can see, there's not like really like a structure to it. Like, you know, the spiral one, you kind of saw like a clear outline, but this one you don't really see that much of like a clear shape going on here. Yeah, the egg galaxy. That actually sounds like something from Mario. And then basically, the stars kind of orbit random direction. Like there's like a core, and it kind of like orbit in like random directions, which kind of like gives it this like unshaped like type going on right here. And there are usually older stars in this type of shape of galaxy. There'll be older stars. Since there's not a lot of like gas, as I mentioned in the beginning, which is needed for the creation of new stars, that's why there'll be a lot of these like older stars in there. So what scientists think is that the reason that there is not much gas and that there is not many like newer stars in this, which and also for the reason why there would be older stars, is because they think that actually a potential is that this type of galaxy could have emerged from like a merger. Like for example, if you had like two spiral type galaxies, maybe they like collided kind of and ended up making this like oh my goodness, that's me. This elliptical type of galaxy, which would make sense why the stars are older and stuff, right? So yeah, that's elliptical galaxies. Yeah, I guess if the Milky Way and Andromeda collide, we could end up with this. We could end up with this. The Milkomeda? Oh my god, is that their ship name? The Milkomeda? That's kind of cute. Yeah, they kissed. And then they made a new galaxy. Okay, next up we have... Isn't it so nice? Actually, I kind of like the way it looks. I don't know. It feels very spacey. You've seen the ship art. So, this is lenticular galaxies. As you can see, it looks like a lens, basically. Yeah, or the pizza. Yeah, you can call it the pizza. The pizza galaxy. Sorry, I think I'm like tripping over myself too much. Looks like milk. Yeah, it's a very disc shape, as you can see. And basically, these types of galaxies will be a crossover between the elliptical and the spiral. You can kind of see it, right? It kind of has like a little bit of that spiraling going on, but a little bit of that like the elliptical shape going on. So it's kind of like a little in between. I guess, you know, if those two merged and they kissed, this would be their baby, you know? So you can kind of see like the disc and the stuff and like... But you don't see any arms going on, right? Which is the characteristic of the spiral ones. I want to pizza that galaxy. What the hell does that even mean? V, thank you! Arigato! Thank you, thank you, thank you. You can put your own toppings on it, make your own. So, lenticular galaxies, they tend to have older stars, kind of like the elliptical galaxies that we saw before. They tend to have older stars and not too many new ones. So, you know, obviously, people, astronomers and stuff are thinking, could this be older galaxies where like maybe the arms around it have kind of faded? You know, like the spiral ones tend to have arms, right? Could it just be, it's like a spiral type, but like an older one where like the arms have faded and that's why there's a bit more older stars? Or it could be that two spirals, again, merged and made this type of galaxy. Kind of similar to the elliptical one. Well, we don't know. We don't know, but these are just theories. These are just theories. Okay, next up we have... I keep on closing my, like... my folder with images because I don't know why. I think I'm like a clean freak. Okay, so next up, there are irregular galaxies. Someone was asking me if there could be like a Minecraft galaxy, and the answer is there could be. There could be a Minecraft galaxy. So there are irregular galaxies, and you know, as you can kind of tell by the name, basically they just have, you know, like weird or like uncommon shapes. So there's kind of like galaxies that are kind of like shaped, you know, maybe like a ring, or like more that are kind of like thin and like stretched out, like a twink. But basically, these galaxies can kind of be like very varying and have like their own characteristics and stuff. And yeah, there could be their mass could be like way like crazy. You know, it could be like, you know, like 100 million times the sun, or like up to like 10 billion. I don't know. It really just depends on how they're shaped and how they look like, you know? But as I kind of mentioned before, people would kind of like theorize that the reason why there could be such like weird looking galaxies is because, again, you know, maybe just some galaxies merged together and made like a really weird shape. We'll never really know. Well, maybe we'll know someday soon. Or maybe another theory could be that like a spiral kind of passed by another galaxy and then they kind of like influenced the other one, and then maybe they lost material. You know, maybe like swooped in some of that material and made it like transform into a weird irregular shape. So maybe there was a normal looking galaxy, and then maybe a spiral came by, and then it made the other galaxy into like a Minecraft galaxy. It's very possible. But yeah, or you know, more collisions and stuff like that. And yeah, since these galaxies could have, you know, a lot of like gas and dust, which are necessary for newer stars. So yeah, that's why some irregular galaxies could some irregular galaxies could have a lot of newer stars, and which is why some astronomers would theorize that yeah, it could just be the result of collisions or like influences of other galaxies nearby and stuff like that. Just to get, I won't get like too much into it, but there are like subcategories and ways of like defining galaxies. So, this one is so pretty, and there's a reason why it's pretty. This one is so pretty. Yeah, it's so pretty. So, there are a subcategory of galaxies called Seyfert galaxies, and they're named after some guy. I don't know that guy. Sorry, guy. Sorry, Mr. Seyfert. But basically, it's a type of active galaxy, which basically it has a lot of infrared radiation, which is why it looks so pretty. First name some, last name guy, and then there are what the hell? Oh, here you go. This is a quasar. So this is actually the closest quasar to Earth. This is our like most closest neighbor. And quasars are basically the most luminous type of active galaxies, which means that it has a lot of light across the electromagnetic spectrum and a lot of like powerful jet particles and stuff, which makes it super bright. Super bright. And this is our nearest guy. What's his name? Markarian 231. And he is about 600 million light years away. But yeah, we've discovered that there's about like 1 million quasars. The furthest one is 13 billion light years away, and this guy is 600 million, the closest one. So yeah, we think that basically quasars are from merging galaxies, which will fuel them, but they won't last very long. So basically is what we think. We think that they're kind of in this state of being like, you know, super bright, you know, and whatever for about like only 10 million years. Because it can't be maintained. And lastly, do I have an image for this? I do not. Okay. Next up we have blazars. So blazars are kind of like quasars where they like produce a lot of light. And it can be, these can be like super well seen from Earth. And they can kind of appear a bit more brightly. And they're like super trackable for us. So it's just kind of like a bit similar to this. Okay. So that was different types of galaxies. I went to the store and bought a quasar. When you have time, can you explain why these stars and galaxies photos look so cool with these colors? Do they really look like that in real life? I think it's just like the I mean, obviously what you can see from the bare eye really like differentiates from what you can see with like really like specific equipment and stuff like that, right? But also I'll kind of bring some like images of like certain stuff which are kind of like, that's not the real accurate color. It's just like a color that's used so you can see it a bit more accurately. But some stuff are like as they appear. It's just, you know, it's kind of hard to see with the naked eye, you know, and they're using like really specific instruments and stuff like that. You also bloom in the darkness. Am I a quasar? Sure, I'll be a quasar. Okay, next up we are going to talk about black holes. Yeah, that's why it's necessary to have these like type of equipments to see it, right? Unless you're like a robot and maybe you have special eyes that can see certain stuff that normal humans can't see. Which I have because I am a robot. Beep boop. Mabushi! Nani ga? Okay. Moving to Yu-Gi-Oh cards, be quiet. Okay, so next up we're gonna be talking about black holes, which obviously there's a lot of, there's a lot of mystery around them. We know a little bit of stuff, but there's a lot of mystery. I don't know, guys. Is there anyone else who can see this with their bare eyes? Because I can. Can I make an Ash Twin project with black holes? Stop! Don't talk about outer wilds. It looks like a shiny donut. It does. Okay, so black holes. Yeah, it's kind of hard to like talk about them because we know a little bit, but we don't know a lot. But it's like some mystery. There's a lot of theories. Like with a lot of stuff in space, there's a lot of theories about it, but looks like your graphics card. What? Your graphics card looks like this? Girl, would you look at a black hole with me? Sure. Outer Wilds mentioned. Thanks for playing. Are you an Outer Wilds dev? Or are you just an Outer Wilds enthusiast? Like me? You a dev? Hold up, I'm sweating right now. Wait, I love Outer Wilds. What the hell? I'm sweating so hard. I went to like a dinner with my family and I was talking about Outer Wilds. Okay. So, let's talk about black holes. And yeah, I think we talked about it a little bit before, but let's see what else we can get out of it. What's the dev? Wow. Hold up, I'm sweating right now. Thank you for making a beautiful game. Wow. I even played the DLC. Wowee. Okay. Black holes. Black holes is basically a super condensed matter in like a tiny space. And I think we might have talked about it before, but oh, where's my hand? Here is my hand. The event horizon is... The event horizon, people think it's kind of like a surface, but it's not really a surface. It's just like a point, like an area, like a line, basically where nothing can escape from it. No one knows what it looks like inside because I don't know if we'll ever know. Maybe we will know one day. Yeah, just like my big head. Shut up. Shut up. Shut up. Yeah, the point of no return of my big head. Event Horizon is a cool movie? Wait, I've never heard of that. What type of movie is that? Yeah, kind of like a point of no return. Exactly. Good way of explaining it. The hand is cute. Shut up. It's on the pointer finger. Don't make it another finger. Oh, it's a horror movie? Oh. And yeah. So the closest black hole that we know is about 1,500 light years away, which is... Oh, thank you for the raid. Welcome. The type of movie you don't need eyes to see. So basically, it is 1.5 light years away. I want to say that's close, but it's definitely not close. That's definitely not close. And the furthest one that we know of is 13 billion light years away. So that's definitely really far away. The 1.5 light years, 1.5k light years isn't close. That one is definitely not close at all. The biggest, like the most massive black hole that we know of is about 66 billion times the mass of our sun. The largest that we know of is about four times the mass of our sun. So the other one is so tiny in comparison to the biggest one that we know. Do any black holes have special names? Yeah, my big head is called Rosemi-sama. Okay, so actually black holes, like, they spin. They have like rotations going on. I think the fastest one that we know of is like about like 1,000 rotations per second. So these things they're spinning. That's crazy. That's crazy. And yeah. They can even like launch particles at like the speed of light because they're like spinning and stuff. It's crazy. Supermassive Rosemi's head. Shut up. Does it suck in a bunch of knowledge in my head? No, everything just goes straight out. It like bounces out of it. And yeah, basically, but so a fact I saw is that if you were to replace the sun with a black hole of this that has like the same gravity, basically the planets would stay in orbit. That's crazy, right? You could like just replace our sun with a black hole and everything would just stay like that. Obviously it'd be a lot colder, so it would kind of like mess up a lot of things, but it could maintain, you know? It's crazy. Supermassive Rosemi-sama. Thank you for the super. Thank you. Who turned off the lights exactly? I kind of want to see that though. I mean, not while I'm alive. Okay, maybe not while any human being is alive. Yeah, a lot of galaxies that are kind of like similar to our Milky Way have black holes at the center. And so our black hole is called the Sagittarius A star, which is about 4 million times the mass of our sun. And so is this okay, here's the image of. You remember this image? The really ominous looking one? The really scary one? I don't know why they had to use that color. This really scary one is our Sagittarius A star. The black hole chan. Oh yeah! People were drawing this. It was like an anime girl. I remember that. Big if true. This is scary. Yeah, the eye of basically the eye of Sauron. Hey, I thought like the image of this was like in the past 2 years. Was it much longer than that? It looks like a flower. Wait, doesn't it kind of look like my eye? Wait. So what if you did this? Oops. Maybe they were a rosebud. We'll never know. Yaba! This kind of works actually. Hey, look, I'm kind of cute. I kind of look like a pian. The Chuni eye. Hey, look, yeah, I told you it'd fit. I'm Chuni. Alright, sorry, let me get it back. Where? Oh no. Oh, there we go. So yeah, this is our guy. Majora's Mask Moon. This is our guy, Sagittarius A star, who, as I mentioned, is 4 million times the mass of our sun. So yeah, obviously, you know, like black holes are kind of they're hard to find. There's no light on them, so it's kind of hard to find. Basically, they're just kind of found with how they affect their environment around it, and stuff like that. The gravity of stars orbiting around them and stuff like that. And then they'll kind of like create like ripples in the fabric of space-time. I hate saying that term because it makes me sound so chuny. Which, oh goodness, what is this BGM? Oh well, it's fine. Which is basically called gravitational waves, and then we can detect these ripples. So it's a bit more trickier to find them, but we can kind of manage and stuff like that. Yeah. They like basically will also like bend the light of like distant objects and stuff. Cosmic pitfalls. Yeah. So yeah, that's black holes. That is black holes. Okay. Next up is... This is something I always wanted to talk about a bit more. Are exoplanets. I feel like it's such like a thrilling thing to talk about. So, exoplanets, it's basically just a planet that's out of our solar system, you know? And it's interesting to look at them, you know, because obviously it comes with like the idea, could there be, you know, life out there, you know? How do things look? Are things similar to our solar system? Could we have like a pattern based off what we know? And could there be life? Could there be life out there? You know, there's so many things that we can think about when you look at them. So yeah, I always wanted to kind of go into this a bit more, but yeah. We're just in a really small corner of the universe, but how are, you know, planets out there? Yeah, like Arrakis. Like Arrakis. Could we hang out there? Could we hang out there? Maybe there can be like a Rosemi-sama Rosebud meetup somewhere in Arrakis. Renzoto could be out there. So, let me see if I can have any images. Ah, this one. This is the depiction of an exoplanet rotating around a star. Okay, so, kind of just like galaxies, we can kind of categorize planets, as you might know. We can categorize, like, even from our planets in our solar system, we can kind of categorize them. And it's the same thing with planets out there. You can kind of, they fall into like a category, but they can be vastly different. So you can categorize them, but they will be nothing like what we know. And there's even planets that we don't have in our, types of planets that we don't have in our solar system. Who's firing a planet at the sun? This looks like the Final Fantasy Ultimate spell. Okay, so Nani? Oh yeah, we had discovered a total of around 6,000 planets. So we have found out 6,000 planets out there. To compare with other numbers, we have found about a bit like 4.5 thousand stars, and we have found 4.5 thousand planetary systems out there. Okay. So the closest exoplanet that we know of is, oh, I don't have a picture of this guy, do I? Is Proxima Centauri. Proxima Centauri b. He is about 4 light years away. So again, far, but not so far? Question mark. Yeah, and in our Milky Way, there's a lot of there's a lot of planets. There are more planets than we have stars in our particular galaxy, and then we have a lot of planets that are kind of like similar to Earth and Venus. So these would fall under the rocky planet category. And then we have gas planets, kind of like Jupiter and Saturn, which can have water or ice or whatever, They can be, and then there can even be other planets that, have a lot of iron or carbon. There's like lava planets and stuff like that. There's so many different types. And yeah. Okay. So let's start off with... What shall we start off with? Let's go with the one that we're showing in the picture. Let's talk about gas giants. Do I have any gas? Yes! Gas giant here. This is an image actually of the hottest gas giant. His name is a bunch of numbers and letters, but I can say it. I think his name was like Kajelt. Kajelt 9B or something. Okay, so gas giants are technically they tend to orbit a bit, kind of like this image I showed you from before. They tend to orbit a bit closer to the star, which means that they'll obviously have a higher temperature. They'll have a higher temperature than a lot of other types of planets. Sometimes he's so hot. Yeah, he is really hot. And yeah, their temperature can go up into like thousands and thousands of degrees, which is kind of crazy. They can have different types of composition. But usually, like types of like Neptune types, for example, will have a lot of hydrogen and helium and have like a rocky type of a core. And then there can be many types of these. There can be like mini Neptune types, which are larger than Earth. That's something that categorizes them. They are larger than Earth, but we have none of these types in our solar system actually. And then also, what other types of planets are there? There are super Earth types. There are super Earth types which are kind of like Earth, but not really. Usually they're a bit bigger. And then there are terrestrial types, which are kind of like our Earth. So yeah. Okay, let's get started with the gas giants. So, as I mentioned, gas giants tend to orbit a bit closer to the stars, and usually gas giants will kind of form in the beginning of a star's lifespan, because it'll tend to be a bit, hotter and stuff like that. And so yeah, in this image, Mr. Kelt is the hottest gas giant that we know, and yeah, basically, gas giants tend to. Sorry, my brain is giving up right now. My brain is giving up. I need to pee really badly. I think I'm gonna go pee first, okay? I also need to turn down the heating in my apartment because it's really hot and I'm like overheating and dying, I think, currently. Go pee? Okay. I'll be back really quickly and I'll turn down the heat. I think I'm literally like dying like a gas giant. Sorry. Okay, I'll be right back. Give me a second. Let me just grab some water and then also let me just turn down the heat and I'll go pee really quickly. I'll be right back. Go ahead to John. Okay, I'll be right back really quickly. Chotomate kudasai. Go pee, professor. Has your teacher ever wanted to go pee in the middle of it? Like, I don't think I recall that happening. But okay, I'll be right back. I just need to turn on the heat because my brain is literally dying right now. Oh, maybe I should have removed some layers. Actually, I think I figured it out. I'm wearing like my stomach heater. my stomach warmer, and then I have like a hand warmer attached to it. So I think that's why I'm dying. On top of wearing like 3 layers, I have a hand warmer and my stomach warmer on, and so I'm like, why am I sweating and feeling like I'm dying? And then I realized why. Our teacher didn't give seminars for over an hour? Yeah, no wonder. Guys, I'm literally like a gas giant right now. I'm at thousands of degrees. But I will be right back. Chottomate. I'm stuffed like a pig in the oven. Literally. Okay. Teachers often have stomach issues because they hold back their pee all day. Okay, 1 second. I'll be right back. Okay, I'm back. So yeah, a lot of the times I don't really like realize how I'm feeling during a stream because I'm so like absorbed in like chatting and stuff with you guys. That like sometimes I'll be really cold and I won't realize I'm like really cold, and sometimes I'll be like super like overheating and I won't really realize it. Welcome back, thank you! Thank you. Okay. Let us continue. I feel a lot better now though. I took off some layers. Okay. Where were we? So this is an ice giant exoplanet. Have I brushed my teeth? What? I mean, like, I brush in the morning and at night. Why? That's such a weird question. Okay. Okay. So yeah. Neptune-type planets tend to have like thick cloud that kind of like blocks a lot of light. So it's kind of hard to tell. It's kind of hard for scientists to kind of tell like what they're like made of and stuff a lot, because they're kind of like blocked, so we can't really like, you know, look at them as precise as we can with other stuff. And we do know though that the more lighted blocks, the larger they usually tend to be. And we've actually discovered one of like Neptune, like a Neptune type planet that has like really clear skies, so we were able to look at it a bit more clearly. And it had water vapor in the atmosphere, so you know, when you think of water, you're like, okay, maybe something can adapt to like the environment. It's obviously like a really thrilling thing to think that like maybe life can kind of like somehow form. But since like Neptune type planets tend to be on the outer parts of the planetary systems, it tends to be really cold there. So yeah, most of them usually are cold. There are a few that could be hot, but most of them tend to be colder. My favorite song about space is HS by Tom Cardy. It's about how awesome Pluto is. I love Pluto. Pluto is literally the twink. I love him. Lucky, thank you. Thank you, thank you. Do you think any animals? What would you consider an animal? Would you consider like a bacteria to be an animal? I could adapt, but I'm just built different. Is mold an animal? Ah, stop, I don't know. Now you're asking me too many questions. I don't know, actually. And then we have Chotomate. Oh, this is an image of a Neptune type. So as I mentioned, Neptune types tend to kind of be like in further away in like the planetary systems from the center. So this is one that's kind of like in his own corner, being cold. Being cold in his old little corner. And then another type. Oh, here, I'll put this in the corner. Maybe this will help a little bit. So we've currently gone over gas giants and Neptune types. We've kind of gone over those two. Next up, let's go over Super Earth. Here's a Super Earth type. So, Super Earth types, we don't have any. We don't have any in our solar system. So, you know, they're a bit more mysterious to us, but there are a lot of them. There are a lot of them out there. These can be really, really hot. So, you know, they can kind of... Here. I have an image of one that's like... Oh, whoops, I don't... Yeah, here you go. An image of one that is like super hot. As you can tell, these are both the same type of planets, but one can be like really hot and one can be a bit less hot. One can have an ocean on it. So there's a lot of big variety of them. Oh yeah, actually this guy's name is Kepler. This guy's name is Kepler 22b. We think that there could be one kind of close to our solar system, but we're not, you know, we're not too sure yet. But there is one at least 6 light years away, which is a frozen one. So they could be frozen, or they could have an ocean that is not frozen, and they could be like super hot. They can have like really big variety of temperatures, going from like burning to like super cold to even like, you know, like a still hot, but in comparison to the other ones, a bit of a more temperate like 70 Celsius and stuff like that. So yeah, these are Super Earth types, and we don't have any. Big variety of them. They're basically, yeah, they're bigger than Earth. They're bigger than Earth, and that's for sure. But they would be smaller than the Neptune, like that you see here in the graph. Okay. Then the last one that we have is like our little guy. Here is a terrestrial type. Terrestrial types usually, I mean, as you would guess from our Earth, you know, usually they have a lot of rock in them, and they can have a lot of iron. The surface can be liquid, you know, like our Earth has a lot of ocean, a lot of ocean. Sometimes they can have a more, you know, gassy atmosphere. And it's theorized that we have a lot of terrestrial types in our solar system. So about maybe like 10 billion of them. So one thing that we do know is... Where's that picture of it? This one here? Some terrestrial types can even like be on like systems that have like two like suns. Imagine having 2 suns. And actually, that kind of helps them actually sometimes to make them be a bit more habitable. Habitable. And yeah, they can. So we think that there is one that is pretty habitable that has 2 suns. At first we thought that there were more. They were more like small terrestrial rocky type planets out there. We thought that there was like 20 to 50% of them, but there's actually a bit less than that. I think there's about like, you know, 10 10% or less. So there are still a lot of planets that are kind of like our Earth, you know. So, and we think that about half of the planetary systems that kind of have a star that's like our sun can have a rocky type planet with liquid on them. So there's a lot of planets that could potentially have, you know, a form of life, you know, potentially maybe growing there. We'll never know. I mean, we will know. Maybe. So yeah. Those are all different types of planets. And as I mentioned, you know, they can just be like, there's so many varieties of them, you know? Here's a Jupiter type one. Here's one kind of like Jupiter. Really, really big one. Gas giant. A big old guy. And there can just be, there's so many like varieties of them. Just, you know, based on how they're formed. You know, at what, like, how big is their star? How close are they to their star? You know, what type of mass and stuff like that. They can all have so many different, like, varieties. And, yeah, it's crazy to think of what they would look like. And, you know, if there's any that are kind of like our Earth. And, you know, what type of life could be growing on them. So, I think it's really fun to think about this. It's fun to, like, look at, you know, what types of, like, drawings or, like, you know, things that we can see of them. You like planets with rings? Yeah! Me too! They look really cool. They look really cool. I feel like when you think of a planet, either you think of like Earth or you think of a planet with rings, right? Do other solar systems have their planets rotate around the sun? Well, yeah, most of them do have like a star, right? And that's mostly how they form and stuff like that. As I mentioned, a lot of, for example, even like a lot of the gas giants will kind of like form in the earlier lifespans of their star, and that's what makes them so hot. A halo ring? I don't know what that is. What's a halo ring? Yes. Okay. Now, let's get... I think this is probably the last thing for today. This is... What is it called? There's a name for this. Oh, Cosmology. Cosmology is just basically a fancy way to talk about the study of the beginning of the universe. But yeah, I wanted to kind of go over, like... I don't know. I wanted to talk a bit more about like the potential end of our universe, but the truth is we don't know, obviously. Oh, Finana, thank you for the raid. Thank you, Finana. Welcome, regards. We are learning about space and all types of cool stuff. Oh, a ring that has cities in it. Is that what the halo thing is? And we just got to the part of talking about the beginning and the end of our universe. So, yeah. What do we know about the beginning and what do we know about the end? And as I mentioned, cosmology is literally just the name for the study of the beginning of our universe, which was, as you might know, and as I have previously mentioned, 13 billion years ago. Ah, Jesse! Thank you for the gift there, Jesse! We have to gift Rosemi, Jesse! Thank you. So, basically what we know about the beginning of the universe was there was a single time where, literally quicker than a second, like a fraction of a second, where basically everything expanded quicker than the speed of light. So, for not even like for a fraction of the second, what happened for this to be the, like, what powered this? Like, where did this energy come from? Like, we don't know. We don't know. The truth is, we actually have no idea. Was like this energy just like a part of, you know, the like space time? Like, where did it? Yeah, hey, you're going too quick. You're going too quick for us. You're gonna get a speeding ticket. A fraction of a fraction of a fraction. Exactly. Yeah, what was going on before that, and what could have potentially triggered that? We'll never know. It's crazy. And it's crazy to think about. Like, what the hell was happening before anything happened? The power of friendship. And so basically, let's see. Oh, it's not. Do I have any pictures? I don't think I have many pictures for this part because there's like nothing really to kind of like. There's nothing to really explain it. Like, what image are you gonna get? Oh, here I have actually a graph that might help. How long ago was that? About 13 billion years. So yeah, the universe is still kind of a baby. So yeah, this was this initial point. Oh, here you go. Oops, sorry, it's a bit small. This was the initial point in time where just everything went. That inflation, that initial part where everything just went quicker than the speed of light for a fraction of a second. And so basically after this inflation of energy kind of occurred, that kind of made, you know, the Big Bang as we know it. In a Big Bang, yeah. Bazinga. And at this point in time, the universe as we know it was like around 18 billion degrees. Now think about it. 18 billion degrees. 18 billion degrees. Holy crap. Yeah, I would get seared to nothing. Like a steak. But I wouldn't even be a steak. I wouldn't even... So basically, there's some funny stuff that actually occurred during this time. This energy kind of transferred to 18 bazingas. Is that like the 18 big booms? Bazinga, 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 bazinga. Yeah, it would be like a vaporized steak. So at this point, matter and light. So there was nucleosynthesis, which basically happened with like protons and neutrons colliding, and this made a lot of the earlier elements. So in the beginning, there was only... Remember how I mentioned hydrogen and helium? They are like the chosen ones, right? They are like 18 bazingas. If you watch Big Bang Theory, I'm sure you'll hear more than 18 bazingas. They're like the chosen elements. 18... No! Don't call him out! Don't give him attention! If you give him attention, he'll crawl out! He's like a cockroach! All of the Timothy Chalmers are gonna come out now. Forged in the mosh pit. Yeah! They were forged in the mosh pit, and they're like the chosen ones. And so basically, in the beginning, that kind of made like all the hydrogen and helium and stuff. And you know what's crazy to like think about? Most of the helium that we have in the universe today was formed in these 5 minutes after the universe kind of like went. That is mostly where all of the helium comes from. So it's like super mega ancient helium. I'm number one. No, you're not. So yeah, most of this helium was from that 5 minutes after the universe's birth. You can say hi to like some of the oldest stuff in the universe. Yeah, he's an OG. Helium is an OG. Think about that when you fill a balloon. And honestly, at this point, most of the nuclei, so you can see here in the graph. Okay, I need to make this bigger. Yeah, as I said, there's the first particles, and then here, the helium and hydrogen. The chosen ones. The chosen ones. But yeah, oh, you can't even see me. This is awkward. There you go. Yeah, the Dai Senpai. The Dai Senpai. Bro was there when the server opened. Exactly. Exactly. And yeah, at this point, most other nuclei hadn't formed yet because it was too hot for these to kind of make like complete atoms. So there was only really like a lot of this hydrogen and helium in the beginning. But then after a while, oh here there's a date here. Okay. This is 3 minutes after. This is 1 microsecond. But after 3,000? Is that okay, I can't really read it. After about 3,000 years, a lot of these first atoms were kind of formed here. After it kind of cooled down a little bit because it was going crazy here. This was like the craziest mosh pit, and then here it kind of like chilled out a little bit. Oh, 380,000 years. Okay, yeah. Which honestly is like nothing in the general grand scheme of time. So yeah, after about this amount of time, 380k, yeah, it cooled enough, and this was kind of called like the age of recombination, where the nuclei could capture electrons and stuff and make these atoms and stuff like that. But the crazy thing is, at this point in time, so before this 380k, the like space as we knew it was kind of like opaque. And you can actually kind of see it here on this image. I didn't think about it, but it was kind of opaque because there were so many of these like electrons that kind of like made like a fog that scattered light. So space looked opaque, which is kind of crazy to think about it. Like space didn't always look like this. It kind of was crazy back then. Me using 13 billion year old helium to make funny squeaky voices. Lucky, thank you. Thank you. Yeah. And so basically, after these 380k years, things kind of cooled down a bit, and then a bit of that fog lifted, so it wasn't as opaque here. It kind of lifted a bit, and it kind of became a bit more, you know, like transparency. And yeah, the universe was miso, the soup. And yeah. Let's see what else we have here. In this graph, yeah, you can see after 200 million years, the first stars were kind of born. One big boom for the star. But before this 200 million years, there was no real stars. The universe was basically kind of dark. It was kind of dark, and as I said before, it was mostly like just a bunch of atoms and like helium and a bit of like heavier stuff. But it was pretty dark, and there were no stars to kind of shine before this point, because the first stars were born only 200 million years after the first inflation. Boom. One big bazinga. After that, yeah, starlight, there wasn't much starlight because there's still like a lot of dense gas around these first stars that kind of had just started forming. And yeah, as I mentioned earlier when we were talking about stars, the first stars kind of started in like colder areas, which had like these dense clouds of gas and dust. But the universe as we kind of know it kind of became transparent-ish with like the light and stuff like that at around 1 billion years. So it kind of, when you look up at these like images or whatever, if you look up, you'll kind of see it starting to look as it does now about 1 billion years after the beginning. And yeah. Let's see what else we have on this graph. So yeah, the first star is at 200 million years. And then after that, we had the formation of our galaxies. And yeah. Now we can see it the way it is. So, the funny thing is, scientists thought that the universe was kind of like... We thought that the universe was kind of like closing in on itself or whatever. They thought this for a really long time. But we found out, and then after that, they were like, "Hold up, that's not happening. It's staying like static." And then they're like, "Hold up, actually, the universe is expanding." And so yeah, the universe is expanding. And it is thought that the universe will continue to expand until the end of time. Which is kind of crazy to think about. This dark energy. Okay, dark energy basically is... Dark energy is like a pressure basically that's driving this acceleration in the universe. And this energy, it makes up like the majority of like all the energy in the space. So it's around like 70% of the energy in all the space. But the thing is, this energy is kind of like... It's kind of weak in comparison to what we... So obviously, you know, we go through like we go through gravity and stuff like that. But if you were to compare dark energy to like gravity, it's really weak, you know? It's like they have the yaoi, you know? Okay, sorry, I gotta stop explaining stuff with this, but you have like the big buff guy, and then you have the little twink. Dark energy is Rosemi's Truny power, yeah. Or like when you pick Eliza and Tekken, she goes dark wave. Exactly. So if you were to think about it on like the scale of like for humans and stuff like that, it doesn't really matter. But it is most energy in the like universe and stuff like that. So out of 70% and stuff like that. Whoa. Exactly, it's weak, but it's everywhere. So obviously, it's important, you know. And yeah, it drives this acceleration that we have in the universe. But as I mentioned, yeah, people think that like the universe will continue to expand forever. And is that the case? Well, I don't know. We're still researching into it, so it could be. Maybe we'll find out something different in the future. But for now, this is what we know. As for the end of our universe, as I've said, is it just gonna keep like accelerate? Is it gonna just keep expanding and accelerating forever? You know, obviously, like a big theory is like the heat death of the universe, which is basically, you know, like galaxies will get so isolated and stars will fade, and then the black holes will start to like dissipate and stuff like that. It could happen. It is a theory. But I mean, it's not confirmed. The theory is just a theory, you know? Could the universe literally rip itself apart? Is that a thing that could happen? Could quantum fluctuations literally just destroy everything? I don't know. We don't know because there's not enough data and there's not enough research and it's really hard to find out. So, but these are some theories that could happen. Yeah, it could be sorcery. It could be. Maybe Saruman, the evil wizard, will end the whole universe. You can't wait for the inevitable heat death of the universe? It could happen. I mean, you won't be around. Trust me, you will not be around. That's the thing, we know so little. We know so little about, like, this is just the beginning of a lot of the, you know, knowledge that we'll get into this. And I'm sure we'll get to know more as time goes on. But will we ever really know that much? I don't know. That's the scary part about, you know, space and the cosmos and things like that. Basically, don't worry about it, babe. Exactly. Exactly, exactly. I think I wanted to get some more images. But I got... Oh, Zebra! I can't believe Professor Rosemi made us buy the book she wrote for the class. Yeah, and it was $300. I love classes. So yeah, that's the potential end. That's the potential end of... How many protons are there in the universe? Actually, I don't know. Let me see. Is there a number for that? The Eddington number is the number of protons in the observable universe. It is calculated 1.5 times 10 point... What the hell? Nani kore? $15 more billion protons? Yeah, there's 15 more billion protons. The 1080? Oh no. Not the NVIDIA 1080. And it all comes back to graphics cards, ladies and gentlemen. Oh, is that okay? Is that 10 to the power of 80? Okay, that's what I was thinking. Because I was like, that did not show properly. I was like, what the hell are they even trying to say by this? That's like about as many of the amount of Lisan Agaib's in the chat! Shut up! Don't talk about him! Don't talk about him! He's gonna pop up! No! Some nice superscripts on format rail, yeah. 1080 degree snowboarding. You can become one too. No, don't rope him in. Lisan Al-Gaib. And yeah, that's that. That was the end of the last thing that I wanted to talk about. So that is our universe. What? How the hell did it come to be? I don't know. What the hell was happening before I just... Was there so many Timothy Chalamets at one point in time before there was anything that everything just went... Because I'm thinking, the more I see them in chat, the more I'm thinking that could be a theory. Question, what planet does the Ren come from? It is unspeakable. I cannot say it. I don't have the right accent to say it. Probably something that sounds like glorb glue. Okay, thank you for the 5 gifted. Thank you. Is he from Andromeda? He has to be much further away. He can't be that close. But yeah, as I said, maybe if we ever do another one of these, next time we can go into a bit more like theoretical, equational stuff. Can you show the Sombrero Galaxy? I feel like I've heard about that. The Sombrero Galaxy. How is this a sombrero? What? Oh, he kind of looks like one sometimes. This looks like a really flat disc. Thank you for the lesson, Rosemi-sama. Space is so much fun to learn about. I know, but it's so crazy because there's so much we don't know. Like, I feel like there's a lot of stuff that we do know as humans. Well, you guys are humans, I'm a realist. And potentially Satan. It's way bigger than a sombrero. Well, maybe there's like a really big space giant. They could be wearing that galaxy as a hat. The Sapphire Galaxy? Because it's a sombrero. Yeah, I feel like there's so much that we know, but there's also so much things that we don't know about. Especially when it comes to the stuff about, like, you know, the beginnings of where we live and stuff like that. It's really scary to think about, but it's also really intriguing. And that's why space is the ultimate terror, but also the most intriguing thing ever. Thank you so much. Thank you so much for the yaka, by the way. Really appreciate it. Arigato. These are my favorite Rosemi streams. Of course you like them, because I'm talking about basically Arrakis. Whatever, Timothy Chalamet. Oh, thank you for the memberships, Timothy Chalamet. Thank you so much. If the moon were a pixel, what is that? If the moon were 1 pixel? A tediously accurate scale model of the solar system. What is this? Tim on Tim gifting? I know, imagine Timothy Chalamet gifts and then another Timothy Chalamet gets it. I'm waiting for that to happen. I'm like looking at who gets the gifted. Can you show Sea-Slide Galaxy? It's my favorite Mario Galaxy. What the hell, man? I think I watched this like one documentary recently, and it was like the way it explained it. Like when it you know when it shows like how big we are on the scale of like our galaxy, and then it like zooms out and then it shows like how big we theorize the universe is. I was like, and then I had it like weird existentialist crisis, and it was like really scary. But then I'm like, wow, maybe nothing matters. Timothy Gradboy. Timothy, thank you for the gifted. Arigato. Oh my god, I think Timothy Chalamet actually got a gifted from Timothy Chalamet. No way. I'm gonna krill. The Tim number is a theoretical number of gifted from a Tim before it is received by Yeah, I mentioned that, yeah. It's expanding quicker and quicker and quicker. So scary. I don't want to think about it. It's really big, but it's not as big as my love for you, Rosemi. Well, thank you so much, Timothy Chalamet. I love it. My whole chat is just Timothy Chalamet. Happy April's Fool, everyone. I didn't know Arrakis had internet service. Yeah. I mean, they are in the future. Did you know there is a map of the known universe 1-to-1 on Gary's mod? What? How do you even load that in? On Gary's mod? Twank Rosemi experiencing the Tim on Tim action. Husky. Jamie, thank you. Thank you for the educational astronomy stream, Rosemi. We've uncovered so much, yet we know too little. Space is truly the next frontier. Yeah. Speaking of, that's why I also think, like... Okay, I know it's, like, funny and anime and stuff like that, but, like... mecha animes are kind of fun sometimes. I once knew a guy who threw a birthday party for an astronaut. He said it wasn't hard, he just had to plan it. Okay, that one is a good one. I like that one. Thank you. I would have turned down Dune to be on the Rosemi Lovelock show. My Arrakis. My Dune. I hate Dune so much. Thank you, Timothy. Oh, Timothy, thank you so... I am so tired of being like, wow, Timothy, thanks for the super chat. Oh my god, Timothy, thanks for the gifted. Timothy, thank you so much for the gifted memberships. Wow. Arigato. Thank you so much. Really appreciate it. Thank you for the astral yapping, Pookie. Is that Brazilian Timothy Chalamet? He's Brazilian! Yet she won't stop mentioning it. Yeah, because I'm traumatized by Dune. Thanks for the class, Rosemi Sensei. I learned a lot about space stuff today. Camille, thank you! Thank you, thank you, thank you. Thank you so much. And Lucky! Thank you so much for the 10 gifted. Arigato. Actually, I really like doing streams like this. Like, I feel like it's fun. And then we can all kind of like, I don't know, maybe learn a fact or two together. It's also really fun to do the dinosaur one and stuff like that. It was a while since our last astronomy stream, and I wasn't really like confident that I could like find or talk about enough stuff for like a while, but I think it went alright. Maybe next time we can see about the next one. I learned stuff that I'll forget by tomorrow. That's how school goes. Thanks, school. If Tim had a friend, he would be a Timothy Chalamet. We should do the Timothy Chalamet look-alike contest. But yeah, I don't know. Maybe I'll see if there's any other like interesting topics also that we can do similar streams to this one. But my heart will always belong to the astronomy ones. I love these ones the most. Mars rover findings? Oh, okay. I'll think about that for the next one. Joe, thank you for the 23 months. Thank you, thank you. After this, I will be doing another funny little stream. The stream ends if I stop smiling. I don't know if that's gonna last for like nothing as long at all, nothing at all, or if it'll keep going. I have no idea, but we'll see. We should do a telescope stream. I wonder if I got a telescope, how good I could get it to work. It'll last until I go pee. Until the heat death of the universe. You can get telescopes cheaply at thrift stores. Really? Wait, really? Yeah. Okay. Wow. I didn't know about that. I didn't know thrift stores would have stuff like telescopes. Oh my god, guys. I was at Big Camera the other time and they had like a really expensive telescope and I'm like, wow. I should go buy one. They're nice. Does anyone have a telescope here? Do you use it often? Okay. You can see my house? Imagine if you just looked in a telescope and you saw Dune, you saw Arrakis. What's a thrift store? A thrift store is like when people get rid of stuff that they don't need. And there's like a bunch of secondhand stuff. You wish you had one. You have one and your folks use it every night. You can in your backyard. Oh, that's awesome. What the hell? That's so cool. Space is boring. Why the hell are you here? If you have one, you'd love to do astrophotography. Yeah. You used to have one to look at grass from the pool. What? Wait, could you see like ants and stuff? Could you see like... What could you see with it? In the grass? Imagine, that'd be so cute. To see a bunch of little ants. Hey, Rosemi, did you know Saturn gained 128 moons last month, making a total of known moons for Saturn 247. 21 of these moons gained were confirmation of lost moons observed decades ago? Wait, how were they lost? What? How are they lost? Aaron, thank you. I saw really high quality grass. Yeah, I think she might be a grass enthusiast. Yeah, each individual little grass. Why does Saturn need so many moons? I know. Everyone needs a vacation. Thank God. Oh, they got lost near Pluto? You know, Pluto needs a moon. Okay, well, I'm going to raid into the next stream, and I will see you guys. Oh, our telescopes became better. That's how they got lost. I'm gonna raid into the next stream, and I will see you guys there for me to never stop smiling. Oh my god, my cheek muscles are gonna hurt so badly. I better rest them while I can. Okay. Thank you so much for watching, guys. It was really, really fun. Thanks for talking about stuff with me. And next time, we'll see if we do another one. Let's learn about more. I never expected this to be like a series once I did the first one. I can't believe we've done 3 of them so far. Okay, let me set it up. Better rest while I can. Keep smiling. I'm not smiling! Whatever. Whatever. I don't even care. I don't even care. B, thank you! Thank you, Barbie, for the 21 months. Arigatos. Space is fun. You know what else is fun, guys? Buy Outer Wilds and play it! I'm sorry, I love Outer Wilds way too much. And I will never stop being annoying about it. Ever. Period. You know what? If anything... Here. Let me show you what I look like. This is me. Crap! Wait, oh, crap! How do I rotate? This is me! Whatever! Whatever, it works, okay? And that's all that matters. Hashtag not sponsored. Yeah, you should play it! You should play it. I bet you have chubby cheeks from all the smile muscles. No, if anything, my cheeks are like mega ripped. You know that like Giga Chad Kazuya picture? That's me. I'm the Giga Chad Kazuya picture because I smile so much. Mewing? Yeah, whatever that is. Thanks for watching! Also, everyone. Thank you. Yeah, let's go! Here's my magic powers! I'm lifting 100 pounds of my cheek muscle. I'm floating around in the vacuum of space. Someone! You're under arrest! Someone who's not Timothy Chalamet. Save me! Anyone but Timothy Chalamet, please.